Hi, in this video we are going to explore about the various uninformed search methods. Uninformed search methods includes breadth first search, uniform cause search, depth first search and depth limited search. Let us look into the algorithms one. Let us consider how the breadth first search is performed in this tree. Let us consider A as the source node here and K as the goal state. K is the goal state. Actually, how BFS is performed. We will start with the root node A. We are checking whether it is a goal. It's not a goal. So what is happening is we will add the children of A. The children of A are B and C. We add them to the queue. So A is visited. The next node in the queue is B. We visit B and we are checking whether B is the goal. B is not the goal state. We end up in adding the children of B, which are D and E. We add D and E to the queue. Now B is visited. The next unvisited node in the queue is C. So we visit C and we are checking whether C is the goal. C is not the goal. So we add the children of C, which are F and G. The next unvisited node is D. We visit D. D is not the goal. So we are adding the children of D, which are H and I. Next in the queue, the unvisited node is E. We check E. It's not the goal state. So we add the children J and K. Next in the queue, the unvisited node is F. We visit F and we check whether it is a goal. It's not the goal. So we add the child of F, which is L. Then we check G. It's not the goal. It has no children. It's visited. And then in the queue, H is the unvisited node. That's the goal. Then I is not the goal. Then J is not the goal. And then comes K, which is the goal state. This is how the breadth first search is performed. Then uniform cost search. With the breadth first search, every edge is having the same cost, wherein uniform cost search, all the edges will not have the same cost. It will differ like this. You could see each of the edges are having a different cost. We are going to see how the uniform cost search is performed. We are going to start from node A. From node A, we can reach either B or C. The path cost to reach B is 5 and the path cost to reach C is 9, out of which the minimal one is 5. So from A, we reach the node B. So the path cost to reach from A to B is 5. From B, we can reach nodes D and E. The total cost to reach D is the sum of the cost to reach from A to B, then B to D. To reach A to B, it is 5 and B to D it is 2. So the total cost to reach D is 7. Now the cost to reach from A to B is 5, then B to E is 8. So the total cost is 13. Now considering the two path cost, we find cost to reach D is minimal. So from B we go to D. Now from D, there are two nodes which are reachable. One is goal node, the other one is E. So from D we go to the goal node G. The total cost to reach G would be the sum of the cost required to reach till D, then the path cost to reach from D to G, which is 6. So 7 plus 6 is 13. The path is A, B, D, G and the path cost is 13. Depth first search. It includes the backtracking technique and then uses the stack data structure. Backtracking, which means we are in the process of searching and we have reached the dead end. We continue with the search after backtracking. In DFS, the same can be formulated as follows. Number one, if the initial state itself is the final state, then it leads to success. We can exit. We have to repeat until you get success or failure. We generate a successor. Suppose if there are no more successors that could be generated, then it leads to failure. We will repeat the step 1 with the initial state to be the current generated successor. Now we are going to perform the DFS. We are going to do the DFS considering the start node as A and the goal node as D. We initially push node A. We are checking whether A is the goal. In this case, A is not the goal. So we are going to take this A and push the children of A, which are B and E. Now let us push the children of A, B and E. Now the top pointer is pointing to the node B. We are checking whether B is going to be the goal. No, B is not the goal. In this case, we will try to push the child of B, which is C. So this is taken away and we are going to push node C. Now check whether C is going to be the goal. No, C is not the goal. Push the child of C, which is D. Now remove this and then place in D. Now the top pointer is pointing to D. Check whether this is going to be the goal node. Yes, this is going to be the goal node. We stop the searching process here. So the path is we started from A, then we came to B, then we came to C, then we came to D. Here we are going to consider the goal node as F. So the same procedure as what we have seen earlier, considering the goal node as D, will be repeated as such. So till now, your E will be there and D node, and the top pointer is pointing to D. Now we will continue for the rest till we find the goal node F. We check whether D is the goal node. No, it's not the goal node. So that is taken away and the top pointer is now pointing to node E. We are checking whether E is going to be the goal node. E is not the goal node. So we are adding the children of E. We add G, F, and the top pointer is now pointing to node F, like this. Here we are checking whether F node is the goal node. Yes, of course, F is going to be the goal node. We stop the searching process here. The advantages of DFS includes, as far as the implementation part, it's so simple. It needs only small memory for the state space. And coming to the breadth-first search, the advantages includes it's guaranteed to find a solution and it will be optimal as well. Looking at the disadvantages, this DFS sometimes it fails to find a solution. Also, it takes a lot of time to find a solution. Disadvantages includes it's complex to implement and it needs a lot of memory for storing the state space. The next search method is the depth limited search. Here we start with the initial node of the problem and we are going to check if the current node is the goal node. Suppose if the current node is matching the goal node, the search process will be complete and the goal is reached. The third point is we are checking the depth limit. If the depth limit is reached, we will stop the searching process. And number 4, explore successors. We will generate the successor nodes from the current node. Then the next step is we will have to recursively repeat steps 2, 3 and 4 until a solution is found. The depth limit is reached or no more successors can be explored. Thank you.